Now let me add a little bit more explanation about how this stochastic gradient descent works. Okay, so this stochastic gradient descent is utilizing this mini batch, which is the subset of our training data, and its opposite term will be full batch. Okay, that involves all the training data items, right? So this is our original loss function that involves all the data item from the first through the nth data item, and then our loss function will involve the loss of each of our data items, and their summation will be our final loss. Also, we can have this additional regularization term. But in the case of mini batch, at a particular step of a gradient descent, and we only use a subset among the n different data items. Okay, so we can at a time of the gradient descent, we can only use 32 data items out of maybe a lot more data items, and or 64 or 128 at a time. So let me give just one example. So suppose we have four different data items like this. So here it is a linear regression problem, and then we have just x values and also target values in the context of a regression problem. And then this is our L2 loss, and this is just an unrolled version or expression that involves four different terms because we have four different data items. And then this is the pressure gradient with respect to A. And so our gradient computation will involve the gradient coming from each of our four data items, right? So computing all these will take a lot of time in case we have lots of data items, but it is only used just one time of a gradient update of our parameter A, right? So at each iteration or each update through our gradient descent, we have to evaluate all these gradients coming from each of our data items like this, right? So instead of using all these four data items, we can use only two of them, okay? So it's like our loss function is only using the first two data items, and then also it will be converted into 2 because it's just taking the average. Okay, and then this gradient value will be also ignoring this part, right? And then instead of the gradient value as 2 when involving all the data items, and then if we just involve the first two data items, and then our gradient will be 0.5, right? And so given the current value of A, and then the step size times 0.5. And so instead of getting 1.8 as a newly updated value, we will obtain 1.95. Okay, and then we do the same thing on updating another parameter b by just using the gradient from the first two data items. Okay, and then in the next gradient descent update, and then we can use the next two data items. Okay, so in this particular case, our mini batch size is just 2 because we are involving only two data items at each gradient descent update. Okay, and so here we will just cycle or circulate through all the data items by just setting the next mini batch size of the data items. Okay, and then suppose we have 10 different data items, and then our mini batch size is 2, and then we will have to do the 5 gradient descent update in order to use all the data items once, right? Yeah, so the first two and the next two and so on, and then 5 iterations. Yeah, we'll use all the data items just once, right? And so in the case of this stochastic gradient descent, and then given this mini batch size as 2, and then if our entire data item, the number of an entire data item is 10, and then divided by 2, which is our mini batch, which is equivalent to 5 iterations, and then this 5 iterations is called the one epoch. Okay, so one epoch means you will cycle through all the data items just once. Okay, and then this is not the end of the gradient descent, right? And if we cycle through all the data items just once, and then we just come back, and then we just reuse the first 2 data items as our next mini batch, right? And that way, this iterations goes on and on, right? But anyways, there's 5 iterations that will touch our data item just once, and then it will be called the one epoch. Okay,